Page 6 of trig. On this page, we're going to be working with the formula A equals 1/2 AB sine C. So basically what this means is, if you have a triangle that's labeled ABC in the corners, vertices, it looks kind of like this. Remember that the sides are labeled with the little letters across from their capital letter counterparts. Okay? Now, look at the letters that are used to actually calculate the area. They are little a, little b, and big C. Notice that there's a relationship here. The angle is always between the two sides that you know. And we call that an included angle. So when the angle is between the two sides, we call that angle included between the two sides. Okay? This area here is actually, this capital A is area, it's not the angle, okay? The angle we would signify by putting a little hat on the A if we want to be specific. Okay, so let's find the area of a triangle that has these sides and this angle. So let's fill this in first. So we'll put 13.6 and we'll put 9.2 for A and little b, and then for angle C we'll put 49 degrees. Okay? We can use the formula as it, oh, I'm doing the wrong problem. We'll come back to this problem later. First we're going to do these problems, okay? So in this one here, we can see that we have two sides and an included angle, right? So we can just name this one A and this one little b, and we can call this big C, and we're fine, okay? So remember, the formula is 1/2 times AB times sine big C. So we're going to put 1/2 times 16 times 28 times the sine of 23 degrees. Okay, so we could just pop that in the calculator and find out what it is. So we could put 0.5, that's a little bit easier to type than 1/2, times 16 times 28 times sine 23. So the answer is 87.5 is the area of this triangle. Okay, that's the area of this triangle. All right, let's go to the next one. So this one, oh good, included angle again. So we have side A, we have side B, and then the included angle is angle C. So we're going to do 1/2 times A, 7.25, times B, 11, times the sine of 56 degrees. And that's going to be, let's see, 0.5 times 7.25 times 11 times sine of 56 degrees. And the answer is 33.1. So that would be this area here, right? Okay. Last one. Well, this was kind of intimidating. 7 plus 3 square root of 5. Now remember, in our class, don't be intimidated by radical signs. Just plug it in the calculator and get a decimal value to use that's less intimidating. So we put 7 plus square, we put exactly what's written there, and we find out that that's actually equal to 13.7. Okay, so now we have two sides, and we don't have the included angle. So how are we supposed to find the area? Well, you might think that you're going to find this length here, but it's easier just to figure out what this angle is, because remember, if you have two of the three angles, you can find the third angle by subtracting everything from 180, right? So I could do 180 minus 67 minus 35. And I know that this unknown angle is 78 degrees now. And now I have included angle between the two sides. So now I can just plug it in. I could put 1/2 times 10 times 13.7 times the sine of 78 degrees. So that would be 0.5 times 10 is 5 times 13.7 times sine of 78. Enter. And the answer is 67. So the area of this triangle is 67. All right, now we can go down to number 2. So find the area of each of the following triangles. this one's pretty easy. It gives us AB sine C straight up. So all we need to do is like multiply all these together. So we're just going to do for A 1/2 times 13.6 times 9.2 times the sine of 49, and that's going to give me the answer. So I'm going to put 0.5 times 13.6 times 9.2 times sine of 49. And the answer is 47.2. That is the area of this triangle A. What about triangle B? Triangle B, ooh, they give us 2 angles and a side. So that's not something that we can use to directly find the area. So let's redraw this. Okay. Angle B is 42.5. Angle A is 33. And side C is 19. So this will be little a and this is little b. And so we would like to have a side angle pair. Or we'd like to have 2 sides and an included angle. And we only have one side. So the first thing we need to do is we need to find one more side. We need to find either A or B. Which one would be easier? Well, I think they're equally easy. Okay? Can we find one of the sides using law of sines or law of cosines? Well, remember the test. Let's check to see if we can use law of sines. Well, to do law of sines, we need to, let's say that we're going to figure out angle side A. Oh, we can't because we have 2 unknowns. We don't know big C and we don't know little a. Okay, we can only have one unknown. Oh, but wait a second. Can't we figure out angle C by using the 2 angles that we already know? What if we did 180 minus 33 minus 42.5? Wouldn't that give us angle C? And then we could use law of sines. Remember, it's always preferable to use law of sines instead of law of cosines because law of sines is easier to do. So the answer is 104.5. 104.5. Now we're going to use law of sines, and remember, law of sines has sine of big C divided by little c equals the sine of big A divided by little a. In this case, our pairs are the A pair and the C pair, so we used A and C. Our unknown is little a, and we want the unknown to be on top, so I'm going to flip this over so that the unknown is on top. It makes it easier to do the algebra. So let's plug in some of these numbers. So little c is 19. Little a is what we're trying to find out. Big C is 104.5. And big A is 33. So let's fill some of those in. So 19 divided by sine of 104.5. What is the sine of 104.5? It is 0.968. And that's equal to the unknown A divided by sine of 33, which is 0.545. How do I isolate the A? I isolate the A by multiplying both sides by 545. By doing that, these cancel out. Then I would be left with little a equals 0.545 times 19 divided by 0.968. Which is 10.7. Okay? So this A value is equal to 10.7. Now that I know the A value, now I have 2 side angle pairs. Or no, I have neighboring sides with an included angle. So now we can use the formula to find the area. We can say area equals 1/2 times 19 times 10.7 times the sine of 42.5 degrees. And now we can find the area of this triangle. Okay, so it would be 0.5 times 19 times 10.7 times sine of 42. Sine of 42.5. 42.5. And the answer is 68.7. That is the area of this triangle. Okay? All right. And last of all, C here, we have, last of all for number 2, but there's a few problems above too. So for this problem here, we have little a, little b, little c, and we have no angles. Okay? So let's draw a triangle. So let's say that little a is 25. We'll say that little b is 14 square root of 2, and little c is square root of 59. Okay? Square root of 59, let's calculate that first. Square root of 59. Oops. Square root 59. That is 7.68. What about 14 square root of 2? What's that? 14 square root of 2. 19.8. 19.8. So this would be 19.8. And this would be 7.68. 7.68. Okay? I need one of these angles. If I had one of these angles, I could figure out the area. Okay? How could I find the angle? Well, let's say that I want to know angle A. How could I find out angle A? Can I find out angle A by doing law of sines? No, I can't, because there's only one side angle pair. So the only way to find angle A is to use law of cosines. So I'm going to relabel angle A so that it's angle C, because the relevant angle you want to be angle C. And then this will be little c that's red, and this will be, so if this is big C, little, let me do the blue ones. So this would be big C in blue. This would be big B in blue. So I'm going to relabel everything now in red. So this would be my red C. This will be my little red C. Since I use C, this one has to be A, big A, and this will be little a. And then B could just be B. Okay, so I'm using the red letters. And if I use the red letters, then the included, the angle that I'm trying to find is big C. So I'm going to use law of cosines with C on, big C on the left. And remember, that looks like this. So we're going to find big C by using law of cosines. Once we find the C, then we can use this side, and the included angle to find 1/2 AB sine C. I'm not going to do it here because we've already done a lot of practice, okay, of that. And it's not that difficult, right? So let's just look through these other problems and see what's different about them, if it's a little bit more tricky or anything. A gardener leaves a triangular plot of his garden for a plant nursery. The two sides of the triangular plot are AC 23.5 and AD 15. They already marked it. Okay. A, if DC is 29, so they're saying this side is 29, find the area of the plot designated for the plant nursery. Okay, so this is very similar to the last one. We have three sides. We don't have any angles, but we would like to find an angle. Okay, so what if we found this angle because it's included between 15 and 23.5? This angle can be found by, I don't know, law of sines or law of cosines. Can it be found with law of sines? No, because there's only one side angle pair here. But we could do law of cosines. If we're going to do law of cosines, then that means that this should be big C instead of A. And if this is big C, this would be little c. And if that's big C, then this should be big A. And this should be little a. Okay? And this could be B and B. Now, how would we find angle C? we're going to use law of cosines. Remember law of cosines, just like we did last time, etc., right? Then we would find angle C. Once we find angle C, then we would have two sides and the included angle, and we could find the area. Okay? All right. So let's do that really quick. I'm going to do this offline and show you the answer, and then we'll continue on because I don't want to make you watch me do this all again, but I will show you the result. Okay? So I'll be back in a sec. Okay, I'm back. So we wrote down the cosine C formula that's written up here. Cosine C right here. It's this one here. We're going to use that one. So a squared plus b squared minus c squared on top. That would be 15 squared, which is a squared, 23.5 squared, which is b squared, and c squared would be 29 squared. On the bottom, I'm going to have 2 times a times b. If I put that in the calculator using the math button, it looks like this, and I end up with negative 0.0904. Then I'm going to take the inverse cosine of both sides, so I'm going to have big C on the left, and I'm going to have 94.2 degrees as my result. Now that I have 95.2 degrees, now I can use the two sides and the included angle to find the area. So I use the area formula right here. Area equals 1/2 times A times B times sine big C is equal to 176. So that's the area of this triangle. Okay, so that was part A. Part B, 0.5 kilograms of herb seeds will cover an area of 150 meters squared. Determine the mass of seeds in kilograms needed to plant the plot with herbs. So this is like a density problem. I can cover this area with 0.5 kilograms in 150 meters squared. In this case, I have 176 meters squared. So there's two ways to do this. One is I can start with 176 meters squared. I'm going to multiply it by this ratio and get kilograms. So in order to cancel out the meters squared, I'm going to put 150 meters squared on the bottom. I'm going to put 0.5 kilograms on top. Meter squareds are going to cancel, and then I'm going to multiply everything else out. And so then I'm going to end up with the number of kilograms that I can spread here. So we 176 times 0.5 divided by 150. That would be 0.587 kilograms. So the other way you could do it is you could make a proportion. So in one case I have 0.5 kilograms over 150 meters squared, and in the other case I have 176 meters squared, and I have an unknown amount of seeds, and so you would just use algebra to figure out that x is 0.587 in this case too. Okay, so either way is fine. Last of all, there is this weird looking problem where I have what they call a regular hexagon. What's a regular hexagon? A regular hexagon is a hexagon with equal sides and equal angles. Okay? Why is this a trig problem? Because hexagons can be cut up so that it becomes triangles. In fact, it's a very famous triangular pattern, and if you've never done one before, maybe it's difficult, but if you've done one, you're going to remember it forever. So a hexagon can be cut up into 6 equilateral triangles. Remember equilateral triangles? Equilateral triangles are special because they have equal sides and they have equal angles. Okay? Because they have equal sides and equal angles, you can figure out a lot from the positions and what they told you. They told us that this distance here was 9, which means that this distance is here. All these distances are 9 because they're equilateral triangles, right? So I'm going to write 9 on every single distance. That's 9. And then the other thing that we want to know is we want to know what angle this is, because now that we have it divided up into 6 triangles, we can see that the way we're going to figure out the area of the entire hexagon is we're going to figure out the area of one of these triangles, and then we're going to multiply it by 6 because there's 6 triangles. So let me draw just this triangle here, and it's 9 by 9 by 9. Okay, All we need to know now is one of these angles. So you're thinking, oh, okay, now I'm going to do law of cosines again. No, you don't need to, because remember, this is an equilateral triangle where all three angles are the same size. All three angles, let's say one angle is x, all three angles are the same and they add up to 180 degrees, which means 3x equals 180, which means each angle is 60 degrees. So we already have everything. We know that the two sides are 9, and we know that the angle is 60 degrees. Now to figure out the area, we just do 1/2 9 times 9 times the sine of 60 degrees, and we're almost done. Sine of 60 degrees is 0.866. You can do that on the calculator to make sure. So it's 1/2 times 81 times 0.866. This is easy. 0.5 times 81 times 0.866. And the answer is 35.1. That is the area of one of these triangles. What is the area of the entire hexagon? 35.1 times 6. 210. 210. Okay? That's it.